This video, we will talk about more of a tangent and a normal line. For guided practice 3, find the points of contact where horizontal tangents meet the curve. Horizontal tangents means your derivative at that point equals to 0. Horizontal line, the slope of a horizontal line is 0. Therefore, if you know this fact, you will working on f prime of x. We assume this is a f of x. So that 1 over square root of x, we know the derivative is negative 1 over 2x square root of x. Derivative for square root of x will be 1 over 2 square root of x. Therefore, for the first one, you will get the negative 1 over 2x square root of x. Plus 2 is the coefficient. Then you have 1 over 2 square root of x. You will get reduce. So your denominator for the first term is 2x square root of x, negative 1, plus 1 over square root of x. We want to get the same denominator so that we can add together. You need to multiply by 2x. Here's 2x. Therefore, you will get denominator that is 2x square root of x. To the top, negative 1 plus 2x. We will set up this derivative equal to 0. Here's the fact. We have a times b. If it's equal to 0, you will get a equal to 0 or b equal to 0. But when you have a over b equal to 0, which means only a equal to 0. This is a rational function. Therefore, if we want to make this derivative equal to 0, which means negative 1 plus 2x equal to 0. Therefore, x equals 1 over 2. We need to figure out the points of contact. Point means coordinates. Therefore, you will substitute this 1/2 into original function. That equals 1 over square root 1 over 2 plus 2 square root 1 over 2. Square root of 1 over 2, you can write down square root of 1 over square root of 2. So you get 1 over square root of 2. Then you will get square root of 2 over 2 because remember 1 over square root of a, we can write down square root of a over a. Therefore, for complex fraction over here, you will get the square root of 2 plus. This is a square root of 2 because 2 times square root of 2 over 2, you will get square root of 2. So you get the 2 square root of 2, which means the points will be 1/2 and 2 square root of 2. This is the point we are looking for. Let's go to guided practice 4. Find the k. If the tangent to this where x equals 2 has a gradient 4, remember tangent, gradient, that means derivative. Where x equals 2, so we can write down f prime of 2 equals 4. So we will get the derivative for this function. Drop down -1. Remember, here is the formula. Coefficient stay, then nx n minus 1. So that you have 2 times, let's focus on the first one, 3x squared plus k is a coefficient 2x. Constant number will be 0. Therefore, we simplify 6x squared plus 2kx. Then we substitute 2 into this x. You will get the 6 times 2 squared plus 2 times k times 2. Then equals 24 plus 4k. We will set up here equals to 4. Then we solve this equation for k. 4k equals, we cross 24 over here, that's minus 24. So you get the negative 20. K equals negative 5. Let's go to guided practice 5. Consider the curve they give you this, where a, b are constant. The normal to this curve at the point where x equals 4 is this function. Find the value of a and b. You have 4x plus y equals 22. You need to figure out the slope of normal line. So we change this one into mx plus b form. So minus 4x plus 22. You could see this slope is negative 4. Therefore, for the slope of a tangent line, we do opposite reciprocal is 1 over 4. Which means when you have f prime of 4, it will be equals 1 over 4, because this is where x equals to 4. Now let's figure out the f prime of x. We know 1 over square root of x, that is negative 1 over 2 x square root of x. Square root of x, that is 1 over 2 square root of x. Therefore, for this f prime of x, look at here. You will get the b is a coefficient, negative 1 over 2 x square root of x. Then plus coefficient is a times 1 over 2 square root of x. So we simplify 2x square root of x, here's negative b, plus a times 2 square root of x. Then you multiply by x top and bottom, so that you will get the same denominator. That is 2x square root of x. And ax minus b. Then you plug in the f prime of 4 equals here 4, that is 4a minus b. 2 times 4 square root of 4. You will get the denominator is 16. 4a minus b. You set up this one equals 1 over 4. So we do cross multiply. We can reduce first because both like denominator here is 4. So you get the 4a minus b equals to 4. That is one equation about a and b. We only get one equation. Since we are looking for two variables, we have to get the system of equation. So how you get the other equation now? Let's go back to the information given. They said it's the normal to this curve at the point where x equals 4 is 4x plus y equals 22. Let's draw the curve. And we know the slope of a tangent line or gradient of tangent line is a positive. Suppose This one is a 4. I just need to draw the slope, make sure it's greater than 0. Yeah, this one is your tangent line. For this tangent line, and then here, this will be normal line. In other words, if I can get this point will be on tangent line, normal line, and also the curve. We know the x equals 4, so that we can get y equals this coordinate. We can plug in y equals negative 4x plus 22. So you will get, this is a 4. For y1, let's work over here. Negative 4 times 4 plus 22. You will get 6. So you get the 4, 6 at this point. This point also on the graph here. Therefore, I need to plug in this x equals 4 and then y equals 6 to this function. Therefore, you will get the 6 equals b over square root of 4 will be 2 plus a times square root of 4 is 2. Let me simplify. Everything multiplied by 2 because I don't want like a fraction here. Everything multiplied by 2 so that you can get the 12 equals b plus 4a. Now I got the 4a plus b equals 12. And also I got the 4a minus b equals 4. So I add together. You will get the 8a. This is 0 equals 16. So a equals 2. Then you plug in any of these. Let me using this one. So I get the 12 equals b plus 4 times 2. B plus 8. Here's 12. Then b equals 4. This will be the solution for A and B.